So SOHCAHTOA is sine, cosine, tangent. Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So if this is your angle and this is your 90 degree, we have to decide where's your opposite, where's your adjacent, and where's your hypotenuse. So if we start here, well, out of those words, well, isn't this adjacent or next to the angle? But so is this one. So both of these are adjacent to the angle. How do we know which one's adjacent? Well, one of them is actually your hypotenuse. Hypotenuse is opposite the 90. So if we're going opposite the 90, that's not the hypotenuse. So doesn't that have to be the hypotenuse? So if this is the hypotenuse, wouldn't this one down here have to be the adjacent? So remember that these are both adjacent, but since this is opposite the 90, this is the hypotenuse, so this is called the adjacent. And so this side that's opposite of the angle is the opposite. Alrighty, so this would be the opposite. So if I want to find sine, cosine, tangent, well, sine right here says opposite hypotenuse. So sine is the opposite divided by the hypotenuse. Always. It's just a fraction for an angle. It's a fraction of opposite over hypotenuse. For cosine, it's adjacent and hypotenuse. So we have adjacent and hypotenuse. And lastly, for tangent, as you can see, it's OA, TOA. That would be opposite over adjacent. I want cotangent, sine, and cosecant for this triangle. So let's start with cotangent. Now what you have to understand for cotangent theta, what that is equal to is the reciprocal of tangent. Tangent is opposite over adjacent, so cotangent would be adjacent over opposite. It's the reciprocal of tangent, so that is tangent flipped. So what I'm going to do is I'm going to look at my picture and go, well, take the adjacent and put it over the opposite. And if we look at this, there's my angle. Isn't 5 your adjacent and 12 your opposite? So what you'll notice here is your adjacent is 5 and your opposite is 12. And that would be cotangent theta. That is, so there are exact values. There's an exact value. Now if I ask for tangent theta, it'd be 12 over 5. Because tangent would be the reciprocal of cotangent. It's kind of the reciprocal back and forth. So next one is I want sine. Well, sine is going to be opposite over hypotenuse. So it's going to be opposite over, wait, hypotenuse is missing. Don't I have to find that to do sine? So how do I find that side? Well, there's different things you could do. You could use trig with these two using tangent, but that's another story. Can we just use Pythagorean theorem to try to find this side? So to calculate this side, let's do that real quick. What we're going to do is we're going to take 5 squared plus 12 squared, and that would equal your hypotenuse squared. We'll call that h. Let's compute this. It'll be 25 plus 144 is equal to h squared, which would be 169 is equal to h squared. Square root both sides, so we have h equals plus or minus 13, which we just want the plus 13 because the negative makes no sense. So we now know that this is 13. So now I want sine. So let's do that. Sine theta is equal to, sine is opposite over hypotenuse, so opposite is 12, and hypotenuse is 13, and I'm done. Okay, my next one wants cosecant. Well, isn't cosecant just a reciprocal of sine? So isn't it just going to be a reciprocal of this? Well, that's kind of nice. They made that easy on us. So if I want cosecant theta, we're just going to do the reciprocal of sine, which is, boom, done. So we are done. We found all the pieces. Now just be careful. Do you see how this became exactly 13? Let's say it didn't break down. Let's say it was the square root of 170. You would put the square root of 170 here, so you put the square root of 170 here, the square root of 170 here. And then this one, you have to multiply top and bottom by the square root of 170. It gets kind of ugly. Just be aware, if it doesn't break down nicely, you have to put square roots, not the decimal answer, at the pieces. So these 13s would be whatever that square root would have been. Just be aware of that in case.